Hello there, welcome back to another video. Today we're going to be talking about integration by parts, and specifically we're going to be going through where this formula even comes from, how we can use it, and specific problems where this formula gets a little bit more complicated. So we'll start today's video with the product rule. Now the product rule is when we have two functions multiplied by each other, and when we take their derivative, we get u prime times v plus v prime times u. So nothing too complicated, this is just copy pasting exactly from derivatives. Now what I'm going to show you is if we take the integral of this and the integral of this side, dx. Well, what happens is this integral cancels out with the derivative since they're inverse functions. So that leaves me with uv is equal to integral of u prime v. And then we can use the fundamental theorem of calculus to say that this is split into two different integrals. So integral of u prime times v plus the integral of v prime times u dx. So far so good, that wasn't too complicated. And now what we're going to do is we're just going to rearrange this formula. We're going to subtract this from both sides, and this will leave us with integral of v prime u dx is equal to uv minus integral of u prime v dx. And that right there is the formula for the integration by parts. So basically what I've just shown you here is that integration by parts is the inverse of product rule. So if in differentiation we use product rule, in integration we use integration by parts. So whenever we have two functions multiplied by each other during integration, we use this formula. Let's start with an example of this in action. Let's take the integral of x squared sine x dx. Now we have to label one of these as v prime and one of these as u. Okay, well, how do we know which one we label? The process that will help us choose is called LIAT. Now LIAT is basically just a mnemonic for the different types of functions that u could be. Now L, logarithmic, is the most desirable u, and I'll explain why in a second. But then it's inverse trig, then it's algebraic, then it's trigonometric, and then it's exponential. So for our u candidate, our least preferable is exponential and our most preferable is logarithmic. Now let me show you why that is the case. As you can see, we have our u here and we have u here, and we also have u over here, but this is u prime, right? And then this matches with a function here, so this is just x squared sine x dx. So what we're going to have to do is we're going to have to find the derivative of u. And in order to make this process easy for us, we need to pick a u value that gets simplified when you take its derivative. Which basically means if I have ln x and I take the derivative of ln x, that's equal to 1 over x, right? So it just got simpler. I went from a logarithmic function to an algebraic function, right? So it got much easier. Now if I take something like e to the x prime, that's just e to the x, right? It doesn't simplify at all, so this is not a preferable candidate because with u we need to simplify it so it's easier for us, right? So that's the thought process behind LIAT. It's just trying to simplify your calculations. Now whatever we pick as u, that's our u, and then whatever's left is our v. So let's take this as an example, x squared sine x. One of this x squared is an algebraic function and sine x is a trig function. So let's look at our LIAT. Well, as you can see, algebraic is above trig, which means that our u candidate will be x squared. So then we can say u is equal to x squared and v prime is equal to sine x. What we've just done is we've written out this integral. Now, what we have to do is we have to take the derivative of u. So derivative of x squared is, so u prime is 2x, and then we have to take the integral of v, because we need to find just v. We need to plug it in here and we need to plug it in here. So the integral of v is negative cosine x, right? So then I can plug in these values into this equation here, and all I need to do then is just simplify, and there's my answer. So that's the logic behind integration by parts. Now to solidify this, let's actually do a question. All right, here we have x squared ln x dx. So again, over here, we need to pick out what is going to be a u and what is going to be a v. So, okay, we have an algebraic function here and we have a logarithmic function here. So let's go back up. Logarithmic is clearly the best option, and then algebraic is in the middle, which means our u value will be ln x, and our v value will be x squared. Okay, sorry, v prime value will be x squared. Okay, great. Now we just need to calculate the integral of x squared. So we need to take the integral of x squared dx, and that will give us our v, which is x cubed over 3, using the inverse power rule. Okay, not too bad. That was pretty easy. And then for our u prime, we find the derivative of ln x, which in this case is 1 over x. Now all we have to do is plug and chug, right? So what I like to do is I like to use like this crisscross method. So first I need to find the pairing between u and v, so these two. So first I set this equal to x cubed over 3 ln x minus the integral of, and then I take this pairing. So now this one will be x cubed over 3 times 1 over x. Okay, great. Now we have our equation. So now we can just simplify this, right? And that's basically our answer. So we get x cubed over 3 ln x. We can't do anything with that. Minus the integral of. And now I can cancel these x's. So I get x squared over 3 dx. So the integral of x squared over 3 dx. And then what I can then do is I can say x cubed over 3 ln x minus, and then the integral of x squared over 3 will be x cubed over 3 times 3 plus c. Always remember the plus c here, because this is not a definite integral, right? This is indefinite, which means plus c. And then what we can then do is we can also factor out x cubed over 3 from this. So we get ln x minus 1 over 3 plus, and then plus c, we can put it anywhere, it doesn't matter, it's always just a constant. So that right there is our final answer. So it's x cubed over 3 times ln x minus 1 over 3. And if we try to find the product rule of this, we will end up with x squared ln x. So it's just the inverse function. I hope that wasn't too bad. Let's move on to the next question. X squared, integral of x cosine 2x dx. Okay, so as you can see, we have x, which is an algebraic function, and we have cosine 2x, which is a trigonometric function. So let's go back. Liat a is above t, which means we will choose our algebraic function as u. So u is equal to x, du over dx will be equal to 1. Okay, that's really nice actually. Okay, and then v prime is equal to cosine 2x, and then v, because we have to take the integral of cosine 2x dx, we'll have to use chain rule for this, but we can use a shortcut. The shortcut says, as we covered in the last video, we can say it's 1 over 2, integral of cosine is sine, so sine 2x. This rule is just an easier way of doing chain rule, especially if it's a very simple composite function. So there we go, we got our u's and our v's. Now again, we do crisscross applesauce with this, so I'll use the red for crisscross applesauce. So first of all, we need to do uv. Okay, uv. So this is equal to x over 2 sine 2x minus, and then I'll use yellow for the next crisscross. That's this. So minus, and then integral of, remember the second one is integral of, and this would just be 1 over 2 sine 2x dx. Okay, great. Now we can start calculating this. So I'll use blue again to calculate. So first of all, x squared over 2 sine 2x, we can't really do much with that, so we'll leave it as it is. Minus, and then the integral of 1 over 2 sine 2x. Again, we can use the same rule. So we can bring out 1 over 2, and it becomes the integral of sine 2x dx, right? Integral of sine 2x will be negative cosine. So be careful about that. It's not the derivative, it's the integral. So it will be negative cosine. So we get x over 2 sine 2x minus 1/2 negative 1/2 cosine x plus c. So remember, this is also a composite function, and we'll use the same rule. So we get negative 1/2 in the front, cosine x plus c, and that leaves us with x over 2 sine 2x plus 1/4 cosine 2x plus c. And that right there is our final answer. So it is a little bit tricky to be organized with this question, but I think what matters here is if you can select the right u value. As long as you select the right u value, you will be fine, and it's just a copy paste of whatever you do. So there's not much thinking involved. But yeah, that should be the right answer. Now this is a hard question, and I'll show you why. You'll see why. E to the x cosine x dx. So again, now we have to choose between an exponential function, so that's e, and a trig function, t. So we go back to Liat, e comes after t. So in this case, our u value will be cosine x, and our v value will be e to the x. So, okay, integral of v prime value. Our integral of e to the x is just e to the x, so that's easy. If we ever get e to the x, you always should pick it as your v prime value, because it's just so simple to integrate, right? Clearly, integration is more difficult than differentiation, which is why we want to have the most easy function to integrate. Okay, that was fine. Then the derivative of cosine x will be negative sine x. Again, be careful about that. Trig functions can trip you up. Now again, let's do our crisscross applesauce. So first we'll do uv. So we get this is equal to e to the x cosine x plus, and then then we'll do the second crisscross applesauce. So this time it'll be minus integral of negative e to the x sine x dx. Okay, and then I'll use blue again to rewrite this. So we can't really simplify the first function much, so it's e to the x cosine x plus, and there's two minuses, so these minuses will cancel out. It'll just be integral of e to the x sine x dx. But as you notice, this is really similar to this main problem here. So that's annoying. But okay, let's try and solve this one as well then. So now we have to, let's add another part to our question. Integral of e to the x sine x dx. Sine is a trig function, e to the x is an exponential function, and we just discussed that the trig function is much easier to take the derivative of. So we got u is equal to sine x, du over dx is equal to cosine x. Okay, great. Then we get v is equal to e to the x, sorry, v prime, and v is also equal to e to the x. Great, and then we can do a little bit of crisscross applesaucing again. So this right here will turn into this. So it becomes e to the x. So first we'll combine these. I'm going to stop color coding. E to the x sine x minus integral of, and then we do crisscross applesauce horizontally, so e to the x cosine x dx. But if you look at this, what we're trying to solve is e to the x cosine x, and we just got the answer. We just refound our question basically. So what do we do now? Well, let's write the entire question as a whole. Let's rewrite the entire equation. So we started off with this integral of e to the x cosine x. So that's what we're trying to find. That's on the left side. Integral of e to the x cosine x dx. Okay, great. And then we set that equal to e to the x cosine x, e to the x cosine x. And then we got the integral of e to the x sine x dx, which is e to the x sine x minus integral of e to the x cosine x. So we get, and then be careful of the sign. In this case, it's a positive sign. So we'll do plus e to the x sine x minus integral of e to the x cosine x dx. Now look at this. I got e to the x cosine dx here, and I got e to the x cosine dx here. So what I can sort of do is I can treat these, I can label this as x. Actually, I can label this as y. I can label this as y as well. So I get y is equal to e to the x cosine x plus e to the x sine x minus y. Now what I can do is I can bring this y to the other side by adding y to both sides. So we get 2y is equal to e to the x cosine x plus e to the x sine x. Now I can isolate y. So y is equal to e to the x cosine x plus e to the x sine x divided by 2. And would you look at that? Now what I can just do is I can plug back in my y, right? My y is e to the integral of e to the x cosine x. So integral of e to the x cosine x dx is equal to e to the x cosine x plus e to the x sine x divided by 2. And look, this is our question. This then is our answer. So we're done. This right here is what we needed to answer with. So this is actually the most difficult type of integration by parts question, and it's called cyclical integration by parts. And it's cyclical because we have to find the question inside our answer and then make an algebraic expression so that we can calculate, so that we can sort of find y. So this right here is our answer, and that was a really long question, but it was just repetition of the same plug and chug that we've been doing across all of these questions. And as you notice, it's very formulaic. It's really repetitive, and it follows the same process. So that is basically it for this video, and I hope you practice this technique a little bit, get familiar with the u's and the v's, and especially with choosing the right u. So memorize LIAT. It's very useful. And on top of that, it's really important. Oh yeah, plus c. Never forget the plus c. Also, it's really important that we stay organized in these kind of questions, because as you can see, it gets kind of long. And if we can't make up this equation at the end of our thing, then it becomes quite difficult to find the answer, right? So always remember, especially with these like minus signs, be careful with the minus signs, and before solving the integral, simplify the integral. So that's sort of like what we did here. We had the integral of minus the integral of 1/2 sine 2x. So I just factored out 1/2. I brought it outside, so that I would just be left with a simple integral, right? So simplify first and then solve. But yeah, that's basically it for this video, and I hope this has helped you in making sense of integration by parts. And I'll see you in the next video where we will talk about partial fractions. So I'll see you then. Bye-bye.